is if the coordinated vertex of the function y is equal to ax squared plus bx plus c is negative 2 comma 3, and the function intersects with the point 1 comma negative 6, and our ultimate goal is solve for the a plus b plus c, and there to note that a plus b plus c is equal to a constant. Now let's think about the graph of our function negative x squared minus 4x minus 1. The reason why we're trying to figure out the graph of our function, even though it is not important when it comes to solving for this question, is because when you go to more advanced SAT math problem, it's hard to solve it if you don't exactly know about the function. Let's write our function down, which is y is equal to negative ax squared plus bx plus c. But we convert this into our vertex form, which was negative x squared minus 4x minus 1. And at first, we know that our a value, which defines the type of our function, is negative, which means the graph will go downward. And if it just goes downward, such as in this way, it will keep going down, which means only the maximum point will exist. And our maximum point is our vertex of our function, which is negative 2 comma 3. So negative 2 comma 3, it will going to be our maximum point. And if we let's just think about other points to graph. But when the value of x is equal to negative 4, when the value of x is equal to negative 4, it will turn to negative, and then negative 4 squared. Then we have negative 4 times negative 4 will turn into positive 16. We have negative 1. And negative 4 squared will turn into positive 6. But we have negative, which means it will turn to negative 16. Plus 16 will turn into 0, and we get negative 1. So when you input the value of negative 4, which will turn to right over here, the y value, which is the output of our function, will going to be negative 1. So we can kind of make a approximate value of our graph. So if we try it, it will turn to something look like this. And it is just the approximate value of it. And this function will pass through the points that we figure out. And this was y is equal to negative x squared minus 4x minus 1, and we figured out that only the maximum point exists as the a value is negative, and the coordinate was negative 2 comma 3. And we picked some other points to graph. So before we solve for this question, let's think about our solutions of this question. And at first, we need to think about how to solve the vertex of the function. And the question mentioned that the vertex of the function is equal to negative 2 comma 3. And secondly, we need to think about finding the variable value of unknown variable, which are a, b, and c through our intersecting points, which will going to be 1 comma negative 6. At first, we know the vertex of this function, which will going to be negative 2 comma 3. And using these values, we can kind of figure out one of these values of ax squared plus bx plus c. But at first, one thing that we know is from this graph, from this function, we can't exactly know about the value of the vertex. So what we need to do is to convert this into a vertex form, which we also call it into a perfect square form. And let's think about the basic format of a vertex form in order to convert this into a vertex form. In last videos, we have learned about the vertex form, that the vertex form is a times x minus p plus q, and that is equal to y, which is part of our function. And if we analyze this vertex form, the A value is just a value that that only affects another type of our function, which means when the A value is greater than 0, the graph will go upward. And when the A value is less than 0, which means when the A value is negative, the graph will go downward. And this is what the A means. And this time we don't know exact value of A, so we cannot see that whether the function goes upward or downward. And for the Q is a value, so Q is a value of the y coordinate of our vertex. And let's think about the value of P. The value of P is always opposite of the x value. So the value of P is equal to opposite, is basically opposite sign of the x value. Now we can kind of convert this function x squared plus bx plus c into a times x minus p plus q is equal to y. One thing that we can know is that the y value of our vertex form is positive 3, which means we can replace it as a value of q. So we can write positive 3, and for the a value there is no information for it, so we can just write down a. And we have x minus p. And we need to remember that we don't really notate the x value in the vertex form. We only notate the value of p. And we know that the value of x of the vertex coordinate is negative 2, which means we write as next. And then p is a value of the opposite sign of the x value, which means the x is negative 2, the opposite sign will going to be a positive 2, and that is equal to y. And for this term, as a part of the step of the vertex form, we need to remember that we usually convert this into a perfect square. But we don't know a value of the a, b, or c, so we only can write a approximate value of our vertex form. But we forgot one thing, that for the x plus 2 is a part of the perfect square, which means this term should be a squared term. And this is our basic vertex form. And this term should also be square. And one thing that we can know from this vertex form is, but one of the information from our question is that this term, which is our vertex form, it passes through the intersecting point 1, negative 6. And we can know one thing from here, that we know that y value is equal to negative 6 and the x value is positive 1. Which means when you input the value of positive 1 to our function right over here, we will going to get an output of our function, which will going to be a negative 6. And we can figure out the unknown variable, which is going to be a. So if you input the value of 1 here, it will going to be a times x is equal to 1 plus 2 is 3. We have square plus 3 is equal to output of our function, which will going to be a negative 6. And from here, we know that positive 3 squared, it will going to be 8 times 9, which is 9a. Then we have plus 3 is equal to negative 6. And we can subtract 3 to the both sides to isolate these terms. And then 3 minus 3 we're going to cancel out. We get 9a is equal to negative 6 minus 3, which will going to be negative 9. And here we can divide a to the both sides. We need to divide 9 to the both sides so that we can isolate the value of a. And 9 and 9 we're going to cancel out as 1. 9 and a 9, we're going to cancel out 1. We will get the A value is equal to negative 1. We figure out the value of A, which means from our original vertex form, A times X minus P, and then square plus Q is equal to Y. We can replace A as negative 1, which will just turn into negative. Now, another thing that I'm going to do in order to find the value of B and C is that I'm going to just extend these terms. If we extend these terms, we're going to get something squared plus something and then something, which we can eventually find the value of A, B, and C. So, if we extend this, we're going to be negative, and then x minus p squared. We know our original function that we got, which is negative, and then x plus 2 squared plus 3 is equal to y. So we can kind of think about this here, that we still have negative, and then x plus 2 squared is x squared, plus 4x plus 4. But we need to be careful that we have negative, which means we need to use distribute property in order to extend this term, which will turn to negative x squared minus 4x minus 4. But we have our leftover, which will going to be positive 3. And that is equal to our y value. And steps here, what we did is we just extended our terms, our expressions, in order to find the values of missing terms. And here we can figure out that negative 4 plus 3 will just turn into positive 1, which if you write it, negative x squared minus 4x plus negative 1. And that is equal to y. And for the a value, we know that it will going to be equal to negative 1, as we have found in the up step. And for the b is a term of a coefficient of the first degree variable, which will turn into negative 4 in this case. And for the c is just a constant without any variable, which will turn into negative 1. But we are not done yet, because our ultimate goal is to solve for the a plus b plus c. A plus b plus c is negative 1 plus negative 4 plus negative 1. Which if we finish our calculation, negative 1 minus 4 will turn to negative 5. And then minus 1 will turn into a negative 6. So we can say that our answer for this question will going to be negative 6. And when it comes to solving for this question, at first, if we kind of review our steps that we did, at first we know that our vertex is negative 2, 3, which means from this negative x squared plus bx plus c, we cannot exactly know about the vertex form, or the vertex. So we kind of convert this into a vertex form to kind of compare and find the value of one of these expressions, one of these variables. And we figure out that our basic formula vertex form is a times x minus p squared plus q is equal to y. A is a value which makes the graph upward or downward, and q is a value of y value of our vertex coordinate, and the p value should always be opposite of our x value. So what we did here is we inputted the value of our coordinate of the vertex, and we kind of completed our vertex form. And we know that the intersecting points are this, which means when you input the value of these coordinates to our original function, it should gives us the value, which means we got a is equal to negative 9, which if we just divide 9, and then 9 it will turn into a, and then negative 9 divided by negative 9 is just negative 1, which will going to be a value is equal to negative 1. So we figure out our first variable, which is negative 1. And first, for the vertex form that we figure out, one thing that I did in order to find the value of each variables, which is b and c, we just extended these terms, but we need to be careful that when you just convert this into into our basic format of quadratic function, we need to be careful of the sign. So we use the distribute property in order to distribute the negative sign. And then we still had the leftover, which will going to be a positive 3. We also need to calculate it. And our last total answer was negative x squared minus 4x minus 1 is equal to y. And they're trying to find the value of a plus p plus b plus c. A value is our leading coefficient, which will going to be negative 1. B is a second, the just variable first power coefficient, which was negative 4. And the last one, C value, is just a constant without any variables. So negative 1, negative 4, negative 1. If you just add it, we get negative 6. Here's our answer for this question. Now let's think about the graph of our function negative x squared minus 4x minus 1. The reason why we're trying to figure out the graph of our function, even though it's not important when it comes to solving for this question, is because when you go to more advanced SAT math problem, it's hard to solve it if you don't exactly know about the function. Let's write our function down, which is y is equal to negative ax squared plus bx plus c. But we convert this into our vertex form, which was negative x squared minus 4x minus 1. And at first, we know that our a value, which defines the type of our function, is negative, which means the graph will go downward. And if it just goes downward, such as in this way, it will keep going down, which means only the maximum point will exist. And our maximum point is our vertex of our function, which is negative 2, 3. So negative 2, 3, it will going to be our maximum point. And if we let's just think about other points to graph. But when the value of x is equal to negative 4, when the value of x is equal to negative 4, it will turn to negative, and then negative 4 squared. Then we have negative 4 times negative 4 will turn into positive 16. We have negative 1. And negative 4 squared will turn into positive 6, but we have negative, which means it will turn to negative 16. Plus 16 will turn into 0, and we get negative 1. So when you input the value of negative 4, which will turn to right over here, the y value, which is the output of our function, will going to be negative 1. So we can kind of make a approximate value of our graph. So if we try it, it will turn into something look like this. And it is just the approximate value of it. And this function will pass through the points that we figure out. And this was y is equal to negative x squared minus 4x minus 1, and we figured out that only the maximum point exists as the a value is negative, and the coordinate was negative 2, 3. And we picked some other points to graph.